So I would, if there's anything that the universe could provide us with, would be a second example of how to do it. You know,
That's right. We are the canaries in the coal mine ourselves, I think.
right? How do you know that? I mean, if you, I am continuously fascinated by my own body, and not in a garish way, just with all the parts that work. You know,
hmm
and
I
and 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 I can bring this to astronomy because that's where I come from.
That's right.
Uh,
I knew you could. If
I
anybody could bring could drag us. Yeah. Okay, I'm not going to interrupt. Go.
well, see, the thing is, like, if you want to understand the universe, you have to understand your relationship with your cat. There you go, right there. Because
Mhm.
the no, I'm being deadly serious. Uh,
I know you are.
because because uh, when it comes to your understanding of time, you and your cat share a fairly recent relationship in terms of a common ancestor. And that relationship is only less than a tenth of the life of this planet while it was producing, life. So this planet was busy producing life for 9/10 of the time and then at some point, your cat uh, ancestor and your ancestor decided to part ways. But the point is that gives you an idea of how long time is, how big the universe is, how long the universe is, all those big numbers that you can't understand. If you can understand your relationship with your cat, you're on your way.
I I'm working on that every day.
Yeah.
So it's a work in progress. Um, but yeah, I mean, well, time in general. It's like, and I guess this is. I mean, if we're going to talk space time or whatever,
Oh, yeah, that's
time,
what we're here for,
time,
right?
right? I mean, uh, I listened to a really interesting podcast the other day, and I mean, I'll keep saying things that are sort of only tangentially related to what you really want to talk about in this
And,
room, and
and
you
then
can
I'll
see
rope you back in. I'll
that's
see how
right.
I can rope you back in. Yeah.
That's yeah. This is the challenge. So I was listening to a podcast, and it was a young woman in her late 20s, early 30s, maybe, whose mission was to try to um, uh, make time last longer or
Huh.
feel like it lasted longer.
Well,
And so there
marijuana
apparently,
does that, but otherwise you're going on beyond that, right?
right, I was going to say there are, so the sad way to do that is by living an absolutely boring, existence, right? Where you watch paint dry and grass grow and,
You
um,
think you think that makes time go slower?
well, it seems
I,
to
I
make
think it
time
does
go
just
slow.
the opposite.
Well, I mean, ultimately so there's a secondary part of this, which is to have wildly new experiences all the time that form new memories.
Hmm.
That's the other end of the continuum. I hear what you're saying, but what I think the missing factor in this is the concept of routine.
Hmm.
um, so routine is the enemy of time, is the one of the main takeaways from this, that to the extent that we do things without thinking about them,
Hmm.
um, that they are, and the older we get, the less we feel we have to think about,
Right.
the things that we do on the daily. um, the the less we have to look back on in terms of having formed new memories or new relationships with things that we regularly encounter. Um, so anyway, suffice it to say that she spent a week um,
Uh-huh.
committed to sleeping in a different bed every night. She was
Uh-huh.
couch surfing, believe it or not,
Uh-huh.
um,
Hmm.
and only eating things that she'd never eaten before, and only
Uh-huh.
doing things that she never did before.
Okay, that's
And
good.
it
Yeah.
it was an exhausting week for her. It's like that ended with her breaking up with her longtime boyfriend. But but like when she looked back on it, she felt like she'd lived 2 or 3 weeks because of the endless array of new memories she'd formed by virtue of having new experiences. Um,
Right.
and then they settled into this like interesting homeostasis where they're like, okay, well that can be exhausting, and it's true, it can. So sometimes it's about being contemplative about places you are all the time. I mean, looking at the scratches on the floor a different way, or taking a new route to work in a city that
Hmm.
you've lived in all your life, or whatever.
Right.
Um, anyway, so
So there's this
you
guy.
can.
There's this guy, scientist whose name I don't like. I don't care to repeat because it's hard for me to repeat. He's Chinese. He's well thought of in the social media community, and he's certainly a PhD scientist with qualifications. Uh, but his most recent take on time is that it doesn't exist. And so whenever somebody really, really well educated speaks up about time, it's really time to leave the room because because they really, as far as I'm concerned, nobody understands what that stuff is. And for that matter, here's my take on it. I think when you're stoned, okay, and you feel like time slows down, I really feel that what happens is it's an old theory of mine, and it's completely unconfirmed except by me. Uh, that and true non-science that when you're stoned, so many normal pathways are broken, and so you can all the little things that your brain says no, don't bother with that one, get come through, and you have 1,000 experiences at the same time you would have only a few, and so you measure time by the number of experiences you've had, and since you've had so many, time must have slowed down. That's the official Whitehill take on time, by the way, and marijuana.
I always appreciate that.
Right.
Have you read any? What is it? Tom Robbins. Have you ever read Even Cowgirls Get the Blues?
No, but I heard the title, but no, I haven't.
I mean, they made a film out of it as well with Uma Thurman and her giant thumbs. But
Oh,
Tom Robbins' take on time. In
Tom
time is a
Robbins, or who's is it? Not Tim Robbins. Tom Robbins. Is he
Tim
the
Robbins is the actor. Tom Robbins is the author. Um,
is he one of these preachers of the way to
um,
Satori?
I don't know the answer to that. I mean,
Hmm. Is he a big tall guy?
I don't know the answer to that either. We've never
Okay.
been in the same room together.
No, I just
But
I think
he's
you're talking about Tony Robbins.
that's exactly who I don't know.
He's really
okay.
tall.
Yes, let's not confuse him with Tony Robbins. Tony Robbins is Tony Robbins is a different strain of human than Tom. I don't know a lot about I don't know a lot about Tom's background, but I'm comfortable saying that he is no Tony and vice versa.
Okay.
Um, but
So what did you say?
quickly, what I will say is that time is a right. It's an artificial construct. I mean, and what's going on in the background of Even Cowgirls Get the Blues is, and I barely remember this because I've probably read a dozen books in my lifetime, and it's been a long time since I picked one up.
Did you
But
just say you've read a dozen books in your lifetime? Okay.
it's I am
Continuing.
illiterate,
Uh,
capable of reading but choose not to. Um, anyway, the natives are building a timekeeping device in the hills, and what it is like a tree with a variety of recycled objects, trash hanging from all the branches. And when the wind moves and the objects hanging in the trees make noise, that marks the passage of time. And
I
so
see.
sometimes it is gusty, and sometimes it is still, and time pulsates that way in interesting ways. But I thought it was philosophically, anyway. Um,
Right, and really, but I just have to say that in the absence of further conversation, time is the one subject that I try to not talk about at all because I have specialized in not knowing anything about it. Uh, uh, because I've been warned, you know. So I know that I shouldn't say anything about time,
That's funny.
and so you can go on, and I'll have absolutely nothing to say in response.
oh, right, that's that's such a liberating position to be in. I can just rant about time.
No, you can't.
That's
I can shut you off.
that's right, and maybe that's the best. I only raised my hand because I you were talking at me, and I felt like maybe I should
No, I
respond.
understand. If you came into the room that and you were the first person, then I would certainly invite you to speak and to, participate in whatever rant we're about to get into. But I was hoping, against hope, mind you.
that it would be about that it would be about
Uh,
astronomy. I
Well, I'm
have
happy to take time to ask a question.
Good evening, Dad.
buddy,
here we go.
uh, there's my daughter in there, and my son-in-law, but they both have the same name, Jack.
Yes, we're both Jack tonight.
Oh, I
We
see.
we were hoping for a riveting conversation about the stars and the galaxies and whatnot. Instead, we're talking about
That's
prostates
right,
and scratches on the floor.
because basically Clubhouse has devolved into meaningless chatter about whatever, and nobody is really interested in astronomy, and I get it, so I could change the name to Ask Doctor Talk Among Yourselves, and
Talk
everybody.
amongst yourselves.
Well, pretty much, except that I'm the only moderator, and that's my claim to fame in this room. I
I,
moderate.
I mean, I think
Ask
what's
an astronomy question.
reasonable. Sorry.
Let me ask an astronomy question because I did come in with two questions.
Oh, astronomy, please, Haris.
I did.
Okay,
Um, I mean, I'm sure
rest of
there's
you
astronomy
stand
applies to
down.
prostate somehow, but that's probably in a different room.
Yeah,
I was curious though from a discussion last week, like the Earth spins in a 24-hour cycle, the Moon goes in a
a
28,
little bit less,
a
24
little bit
hours, and
less,
a little bit less.
right?
Yeah,
And the Moon circles the Earth every 28 days. Like why? Like
more or
what is it
less.
about the dynamic between the Earth and the Moon that the Moon isn't doesn't spin with the Earth in a 24-hour cycle?
I mean, why doesn't the moon go around the Earth every 24 hours?
Yeah.
Uh, mm, well, why would it? Is another way to respond to that. Why would it go? In other
Well,
words,
what is
you've
it?
chosen an arbitrary number which happens to coincide with the spin of the Earth. Okay, but if it
Yeah.
went around as fast as the Earth did, like as if the Earth was a lollipop with a stick sticking out of it and the moon was attached, uh, the the gravity of the Earth would not be sufficient to hold that lollipop end, the other end, in. It would, the moon would go flying off into outer space. There's not enough gravity to hold it, no matter how close it gets to the Earth.
Okay, okay.
But here's the kicker. Long time ago, when the Earth was just a puppy, the moon was going around the Earth much more quickly, and the Earth was spinning that much more quickly as well. So maybe the Earth spun every 10, 12 hours, and maybe a month was more like a few days. That was
Oh,
at the
okay.
beginning, and then subsequently the tides, those ornery things that do a little number every 6, 12 hours, were capable of grabbing the little handles of the Earth and sort of slowing it down while it moved further out. It exchanged angular momentum between the Earth and the Moon. Together, they didn't change their angular momentum, but the Moon went out further and gained angular momentum, and the Earth slowed down and lost angular momentum.
Oh, that's a great answer. Okay. So I knew it wasn't a stupid question. That was
No,
a
no, no,
great
it
answer.
wasn't. It wasn't. In fact, you want to know what a stupid question is? Stupid question is, why is the Earth 93 million miles away from the sun? That's a stupid question. And the reason that that's a stupid question is because there isn't an answer. And why would you think there was? And you would think, well, the Earth was put there to be 93. No, no, it happened to be. It happened to be. And given that we need that kind of distance from the sun not to be burned to a cinder, that gave us the ability to turn into a communicating, somewhat intelligent species.
So, like in a billion years, like with the way the moon continually goes a little bit further out each year, like a day may be 30 hours, and
Right. And the moon will be
in a
further
month
away.
will expand out to 40 days or something like that.
And and
That's fascinating.
the
Okay.
phenomenon of a total solar eclipse will disappear. So
Oh,
you
wow,
can
that's
actually look
good.
up how long we have before we no longer get total eclipses of the sun. And I'm going to make up a number, and I'm going to go with something like maybe 20 million years, 10 million years, maybe. It could be off by a whole factor of 10, or more, but not tomorrow is the point.
How
So we,
many solar eclipses are like? Because since the moon passes between the Earth and Moon every 28 days, does
right.
that mean there's a solar eclipse on the Earth somewhere every 28 days?
No, no, uh, not at all. And this is one of these questions that has have a great set of answers, of which I'm only privy to a few, uh, because I basically haven't paid attention. Uh, so, uh, so the basic story is that the Earth and the Sun form a line between the two of them, right? And uh, and in order for the Moon to eclipse the Sun, it has to pass through that line. But the Moon doesn't pass through that line very often. Uh, so
Oh,
there's only uh, one or two eclipses a year at most, generally. But when they do occur, they occur with a certain pattern that is interesting because the ancients 2,000 years ago knew the pattern of the solar eclipses, and there is a device called the Antikythera mechanism, which was found off the coast of Antikythera, which is a small island near Kythera in the Greek islands. And they found this encrusted metal object, which, upon study for decades, has revealed that it was capable of predicting solar eclipses. And they come in pairs generally. Uh, in other words, they come uh, uh, once and then they come again soon after, and then they pause for a number of years from where you are, and they don't come again for a while, and then they come again. So that's about, and there's a word for that, and I forget the name of it. Uh, but the ancients knew it, and we don't, because we only watch television.
wow. Well, of one last question, I'm sure there's others want
And
to
please
go.
don't make it the last question. We have John Frederick in the room, and he's always good with a question. Jack sometimes, uh, Jack sometimes, Jack sometimes, Ellen never, but always a good shill. Uh, and so anyway, go on.
Like we know like what like they're just like with satellites going around the Earth, like we know certainly uh a certain height, a certain altitude,
Hmm.
gravity will eventually take over and pull it down into orbit. Like how high can a satellite go before that the spinning would kind of slingshot the satellite away from the orbit?
Well, in an ideal universe in which we only have the Earth and the Moon, forget the Sun. We can't forget the Sun, but for the purposes of this, in an ideal universe consisting of two bodies, uh, then basically the two of them are joined forever at the hip, just increasingly weakly. But there is it would go through an infinite amount of time before one would lose, if you will, contact with the other. They would be orbiting each other forever, just further and further away because of a tidal thing. Okay. Now,
Ah,
now, if you throw in the sun, okay, into this little equation, then the sun
okay.
has an opinion as to where the moon should go. And while it's not a very heavy opinion, it is, in fact, it's important long term. So, long term, you can't really predict where the moon will be a million years from now, but you can sort of say it won't be doing what it's doing now. It will be doing something different. And and so there's a concept in astronomy called the Hill sphere, and it is a sphere surrounding a planet or a body of any sort, for which that body is capable of ruling the space around it. Uh, but beyond that place, other objects which have equal importance can decide where that object would go if it happens to be outside of this Hill sphere. For example, our solar system is is pretty much 1 light year in radius. 1 light year in radius. Why one versus two? Because the solar system's Hill sphere is 1 light year. Why one? Because passing stars on the average screw up our solar system if anything goes beyond 1 light year. So we own a 1 light year worth of territory. Uh, and each object in the universe has sort of an ownership of what it can control. But only in an ideal sense, because as soon as you throw in other objects, then things get pretty complicated. So this is just an idealized situation. So
Gotcha.
the diameter of the solar system is arbitrarily defined as 1 light year, more or less.
Wow. Great. Thank you.
Yeah, I find that really interesting, especially since it means uh, that it takes into account the idea that passing stars can, in fact, mess with our own solar system, and uh, there are planetesimals or dwarf planets which have no explanation as to how they achieve their orbits unless you take into account the idea that passing stars may have messed with them or even exchanged planetesimals with passing stars. Uh, a particular star object is called Sedna, and Sedna is really it's cute. Neptune has a grand influence on things like Pluto. So Pluto and Neptune kind of avoid each other because otherwise they crash into one another. So that's been decided over the millennia so that Neptune and Pluto sort of don't interact or are called within resonance. But 3 times further away from the sun than Neptune is from the sun is the closest point that Sedna ever comes to the sun.
Oh,
So
well,
Neptune cannot be charged with the deed of having thrown Sedna into its orbit. It doesn't qualify. It's not powerful enough. Maybe Planet X or Planet 9 might be the culprit, and that's one of the arguments for Planet 9. But in the absence of Planet Nine, you have to go resort to crazier explanations. For example, another crazy explanation that I like because I don't understand it is that uh, they sometimes blame the entire galaxy for Sedna's orbit. They say, a little bit here, a little bit there, but the Earth goes up and down uh, 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 above and below the galaxy all the time, and the tidal force of the galaxy itself could perhaps have had something to do with Sedna's orbit. So it's really interesting stuff, but it all has to do with, who's in charge and over what time period is that in charge phenomenon taking place.
wow, that's really interesting.
Yeah, that's why I play with this stuff because it is, to my mind, it gives me a sense of the uh, the uh, the the game of pinball that the planets play with each other, and it's really much more significant than you would think. Planets have been playing with each other for millennia, and the Earth has been among them. We just got lucky to where we are right now.
So does then our nearest solar system star Alpha no like I'm thinking of Sagittarius, Alpha Centauri. Like, does that solar system have any noticeable influence on our solar system?
Not really, but if you count all the other stars and you add their influence, itty bitty bit of
Oh,
time.
gotcha.
I
Sure,
mean,
sure.
there is a place. If you look up in the sky, there's a place called the center of the galaxy, and it's got more stuff. So our planet is being influenced by that stuff more than it is by the stuff off to the side.
Gotcha.
Yeah,
Well, thank you, Doctor.
yeah. I think my daughter and son-in-law disappeared. Uh, they are Alan. They're living in Manhattan right now, and I'm upstate New York.
Oh, they came back from Portugal.
They are trapped in the States.
Oh,
Uh, uh,
okay.
no, really, they are. They have to. They are waiting their visa so they can legally move to Portugal. They have an apartment there. My grandson's in school there, and they're trapped in the States awaiting a visa. And
uh,
the stupid stuff is uh, that Tara and Orion got their visa, but Jack did not, and they applied at the same instant in time. Uh,
oh
so
wow.
so that's and of course there's no words on this. So as I said, they're trapped. That is my grandson who just showed up in there, and if you see the picture of him, uh, he he, uh, he wears headphones from morning till night because he's dedicated to his music. Uh, and that's a good picture of him. I like it. You take a picture of that. Yeah.
I loved it when he counted down from 20 in Greek.
Yeah.
That was
And,
great.
and one of the things that really is sad is that he, in order to keep up his Greek lessons, he was getting Greek tutoring, but he hasn't had his Greek tutoring in a while. So, there are
Oh,
lots
that's
of
true.
losses while they have to stay, in, you know, cooped up in New York City with all the things that New York City has to offer. They're cooped up here, uh, unable to go where they want, which is Portugal.
The other day, we did an excursion, a pilgrimage, if you will, to Astoria, to the Greek neighborhood.
Ah, how did that work out?
It was a bit sad because I had Googled Greek bookstore as a reference point, and when
Yeah.
we got there, there were no Greeks. There was no Greek books. It was un-Greek. But we did go to a couple restaurants where, at the first Greek restaurant we went to, he refused to speak Greek to anybody. He was too timid.
Mm.
And then the second Greek restaurant, he accidentally pushed over a motorcycle in front of the restaurant.
Oh.
And so we had to rush inside, and I looked at him, and in his ear I said, "Now you speak Greek, for the love of God."
And did he?
No, but
Oh.
the he was still too well. It was pretty scary actually because the motorcycle fell almost on top of him.
Oh,
Oh.
But there was a Greek grandma at the as the hostess. It was a family owned restaurant, and I explained to her what had just happened because the motorcycle really crunched down on the sidewalk pretty hard,
Mm.
and I was expecting to pay a handsome fine
Yeah.
for that.
Right.
And the first thing she did was pick him up and then give him a big squeeze, and in Greek asked him if he was okay.
Uh-huh.
So that was lovely.
Did he respond in any kind?
He wanted ice cream. He said,
In Greek. In Greek?
No, to me in English.
Oh God.
But we it was interesting because the lady had sent out one of her cooks to check on the motorcycle, who came back in a huff and ignored us. And I think that was a sign that said, you're allowed to go now.
Okay.
So,
How did he push
needless to
over a
say,
motorcycle?
he just kind of went up to it and pushed. Or he wanted to probably ring the bell like
Uh,
he's seen so many other scooters have. But
right.
needless to say, you and I and the rest of the family are going to a Greek restaurant in Astoria sometime soon
That
as
sounds
an
good.
as a
Right.
thank you.
Let's spend the whole day there and force him to navigate. He'll be the guide, and we'll tell him where we want to go, and he has to get us there.
I do have a astronomy related question
Oh,
that
good.
comes from him.
Okay.
I was trying to figure out if it would be better for him to directly ask you in person when he sees you tomorrow, or if we should use this forum. For the sake
Let's
of,
try this way.
yeah, I was going to say, for the sake of using up time on this platform,
Excellent.
um, he wants to know, and it was something that I tried explaining to him, but my explanation is not good enough for a 4-year old. Why? Why is it that it's cold outside even though we can see the sun?
Oh, wow. That's such a good question.
Why is it cold outside when even though we can see the sun?
Sure, because he
Right.
said he could see the sun in June and it's warm, but now we can see
Right.
the sun and it's cold. It's still there.
Yeah.
And he said, if the
Yeah.
sun is what's keeping us warm, what's the deal?
That's that's one of the least stupid questions I've ever heard. Really.
That's an appropriate question for a 4-year-old.
Right. No, that really is. How would you? Let me try to explain it uh, as to my normal way, and then let me see if I can dial it down. Okay. Uh, um, Even that is hard to make it simple. Uh, okay. Um, uh, so obviously there are a few. Obviously, there are a few things going on. One is that the sun comes in on a slant during the winter. There is it's coming in not directly overhead, so it isn't as intense. That's number one. Number two is the days are shorter, so the sun doesn't get as much time to heat uh, the planet. But that still doesn't explain his question, because he's wondering why, when the sun is up, he doesn't feel warm. Period. And that's sort of independent of the season. He should feel warm when it's up and not cool when it's not, not in the opposite when it's not. Uh, so that has to do really with something I'm trying to explain. It has to do with the fact that the planet retains a certain amount of heat, uh, and with the sun not having enough time to heat the atmosphere, uh, there's not enough time for the air to get hot during the day. Uh, so it's the air that makes him warm. The sun doesn't make him warm. You can stay.
Oh, that's a good.
You can step away from the sun and still feel warm in the summer and cool in the winter. I'm sorry, not speaking that right, but it's the atmosphere that keeps you warm. Uh, and and the question is, so really that would be the way that I would tackle it. Uh, I would do it as an experiment. I would say, I would have him, when he's in front of the sun, when he's in the sun, uh, have him walk into the shade and ask him what happened. And the answer is, well, it got a little colder, but it's still whatever the temperature was before. In other words, it's not the sun that's warming him, it's the air that's warming him. And once he gets that, then it'll make, I think, a lot more sense. So that's where I would go with it. The air is, and there's not enough time for the sun to heat the air in the winter because it's a short days. That's what I would go with.
Or maybe the easy way is just to tell him to ask a meteorologist.
Right, right.
What does
No,
this have to do with my prostate?
but nothing. But
Am
we
I in
we
the
t-
wrong room?
yes, you are. No, see, I was going to turn the prostate conversation into evolution. So that's where I would go. We start with prostate. I'm going to evolution straight up. So we can't bring it back to my prostate.
If you go into the chat, there is somebody who is no longer here named Nirvana who wanted to ask you about treating cancer using stem cells. And we've explained to her that you're not that kind of doctor.
No, no, yeah, right. That's true. But I do have an opinion, which is if you screw around with stem cells, you might give yourself cancer. That's about the only thing I can offer. In other words, stem cells are, by their very nature, able to do anything, including uh, uh, become cancerous. So that's as far as I know. Uh, and I don't normally what you talk about is treating a condition with stem cells. Some sort of condition. You you need to build yourself an organ that you don't have, like pancreas. So you use stem cells to create a pancreas out of nothing. But in the process of doing that, you risk creating other cells as well. But I'm no doctor. I'm just a doctor of astronomy. Right. Right.
Well, can I
Exactly.
ask a follow up question to Jax? Actually,
Yeah.
like the Parker solar probe that's circling the sun right now,
Mm.
like the umbrella in front of its payload, getting the full brunt of the corona, but like behind its heat shield, it's like room temperature. It's like
Mm.
what is it about heat in space that can create such, I guess, differentials versus on when that when the sun hits our atmosphere, like heat I, is different.
I'm not sure what the question is, but I have the answer anyway.
All right, thank you.
Okay.
That was a very inarticulate question.
Right. So the thing is, but it's actually quite on topic with Jack's question from Orion. It's in fact enormously on topic. Uh, do you see the relationship between Jack's question and your question before I begin?
Yes, that's why I
Oh,
asked
you
you.
do. Okay, good, good. So then I won't uh, uh, treat you as a completely uh, unknowing random
Five years old,
question.
not for
In fact, you gave me the right question. In fact, thank you for the right question, which you obviously had thought up as in response to my answer to Orion, because the sun heats the atmosphere, and the atmosphere heats you.
right.
So that's how you get warm. Okay, but the Parker Solar Probe is very close to the sun. I think closer than Mercury, and is capable of not overheating because it has an umbrella. Uh, but if you went out into the hot noonday sun on Earth in India with an umbrella, you'd still steam yourself. Uh, it would get really hot. It's because the atmosphere is still hot. Okay, the thing about the atmosphere around the Parker Solar Probe is the sun's atmosphere, which is what it's entering, because it does enter the sun's atmosphere,
Mm.
is so diffuse that despite the fact that the temperature of the sun's atmosphere is like a couple of million degrees, it's not sufficient. It doesn't have enough heat, which is distinguished from temperature. It doesn't have enough
Mm.
heat
Mm.
to
Mm.
cause the 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 back of the solar probe to get warm. Most people don't distinguish between heat and temperature. It's hot out, the temperature is high.
Right.
There's a lot of heat. This room is hot. but but the heat is really has to do with energy. Energy is a form of heat, whereas temperature is just the number, and it doesn't measure heat. Though in our world, since we live in the atmosphere, it seems as if temperature is a measure of heat, but it's not. It's just our experience of it at one atmosphere. As you go up higher, the
Okay.
temperature of the atmosphere gets higher and it gets colder.
Right. Right. I guess then, like, is there what's the quality of our atmosphere that creates our experience of heat versus the Parker solar probe and its experience of the sun's
The,
heat?
as we go up higher, I think the temperature of the atmosphere gets up as high as 1,000 degrees, something like that. Not up in the clouds. The clouds it's freezing cold, and when the jet planes fly, it's freezing cold. Uh, but higher than that, higher than balloons go, uh, the atmosphere suddenly becomes hot while at the same time being
Oh,
cold.
oh, oh, okay, okay. I see what you're saying. Oh, that's interesting. You're
It's a
Yeah,
dry heat.
it's a dry heat. Thank you very much.
right.
That's true. It is a dry heat.
I live in Denver, so I know what that means.
I actually don't because I'm not a meteorologist, so I really don't know what a dry heat is. I mean, I do from common experience, but I don't really know why when it's dry. Hold on a second. Oops, oops. When it's dry out, it's getting much higher temperatures in the atmosphere because relative humidity is low because high temperatures can produce lower relative humidity. If there's not a lot of humidity in the air, there's plenty of room for your skin to evaporate. And when your skin evaporates water, you feel cooler. So dry heat is simply a matter of having a place for the water in your skin to go.
Wow, so a lot of this is just a matter of perception.
No, I think it's real. I mean, you really can cool off. You can live in Arizona. Not these days sometimes because the heat goes ridiculous, but normally the dry heat is something you can survive. You know,
True. Yeah.
right? Uh, I remember I was a Burning Man and it was hot and it wasn't bad. I've never. Oh, and I've been. Oh, and in. I've been in the desert, the Negev desert, and uh, a camel expedition, and the camels carried our water, and we were instructed to drink, a couple of gallons of water a day, otherwise we would not survive very well. My son, being one of those people who didn't follow the rules, didn't survive very well. He got an enormous headache. Uh,
Ooh.
really, it's not fun, especially when we hit one of those singing dunes, and he couldn't slide down them because his head hurt. But but that's because you need to evaporate the water in the dry heat. Otherwise, your body temperature, your brain temperature, gets too high, and he didn't do that. So that's in dry heat. You need to drink, even if the camel that's carrying your water is producing extremely hot water for you to drink. It's the thing to do. I learned to drink hot water that day.
Absolutely.
Right.
That day.
That day, right? That day, right? Right. Okay. Uh, so, what should we talk about next? I do. I like the way this conversation has gone so far. It gives me a chance to expound on who knows what.
Well,
Well,
I have another atmosphere. Oh, I'm sorry. If you have a question, go ahead.
Yeah. Go.
oh, is that
I think
me?
you would. Yeah, that was you.
Oh, okay. Well, so okay, mine was high. First of all,
Hi.
hello. So mine was a little bit more wrangling back to the astronomy side because we got treated recently to a new picture of Uranus.
I did see that. I did see that.
Yeah, and so it's spellbinding, but it also got me to go down a rabbit hole about why Uranus is tipped on its side. And
Uh-huh.
apparently, there's a study that showed that it might not have been a massive impact, but in fact, it got dragged over by a moon, which no longer
Uh-huh.
exists.
Oh.
And so this was I believe, a French study from the Paris Observatory, where they figured that it's possible that the resonance with a moon and an already kind of wobbly or wobbly axis allowed a moon to progressively drag Uranus over, and then because of this effect, the moon actually receded into Uranus and got absorbed,
Uh-huh.
and then left it tipped over.
Ah.
So
Uh-huh. That's
I
interesting.
so this question is in several parts, but item number one, is
Okay.
a wobbly orbit more like, not orbit, what am I talking about? Is a wobbly axis more likely in a more distant planet? And would this not have been so readily possible for, say, Jupiter? Because
Uh,
if,
yeah.
yep,
Go ahead. Go ahead.
because if Jupiter had been tipped over and Galileo had looked at Jupiter and its moons were obviously going around it,
Mm.
then there would have been no contest there. It would have been a very simple thing to see,
Yeah.
possibly less simple to, well, also simple to time, but a transit of a moon is very obvious. You know, you just
Easy.
watch a dark spot, that's easy. So
Yeah.
maybe the observations would have been easier with with moons in the ecliptic plane rather than, going around at 90 degrees to the ecliptic. But then
Sure.
I think about exoplanets and how we detect exoplanets.
Mm.
And largely that's because of planets transiting across the star, and we are observing them pretty much in their ecliptic plane.
Right.
How good are we at finding exoplanets that are not in the ecliptic plane?
Pretty poor.
Pretty poor. So we're
Yeah.
not we don't have a good method, or they have to
Well,
be really really massive to jiggle the star.
yeah, exactly, exactly true. For example, if it doesn't pass in front of the star, then it can still jiggle the star, assuming it's not in the ecliptic plane, if you will, of the star, uh, but in fact still able to pull it forward and backwards in our line of sight. And if it's able to pull it forward and backwards in our line of sight, it will change the rate at which that star is moving uh, towards us and away from us, and so we can see it. But the planet has to be massive, relatively, for us to find it, and that is how many exoplanets have been found. But the transit method has found most of them. You can only find the big. You can only find the special cases where you have massive planets close by. Uh, and if we're looking, we'd like to find an Earth-like planet around an Earth-like star, and that doesn't do much jiggling. So the thing about Neptune, uh, uh, there, there is a story that I don't know very well, but when you say jiggling, you see, I didn't read that paper or the the article about that paper, but the word jiggling sort of I don't know what that means. Usually, up when something goes around something, it doesn't so much jiggle it as just keeps going around it, forever in the same orbit. And to the extent that it doesn't go around it forever in the same orbit, you have to ask what's going on that causes it to change its orbit and maybe, as you said, jiggle. Uh, and and so the kinds of things that might do that is the influence of a third body, because two bodies go around forever in the same orbit, but you put a third one in, and then all hell breaks loose in terms of predictability. It's called a three-body problem, and it's essentially insolvable except in special cases. Otherwise, you just put it into a computer, and the computer iterates one little bit at a time and figures out where it goes. Uh, so I don't know what jiggled the moon that fell into Uranus. I do know that there's an interesting concept, which is the moon might have been going around in the wrong direction. In other words, retrograde. The moons of Jupiter and Saturn and Uranus and Neptune, they all go around in the right direction, uh, prograde, in the same direction that the planet spins. But if you look at Jupiter and Saturn, and you say, well, let's look at them all, you find that as you go further and further out from Jupiter and from Saturn, the the moons no longer behave in an ordinary way, prograde. Many of them are retrograde, but they're further out. So they're allowed to do that because they were formed in a different process than the process by which the inner moons were formed. Uh, so if there was a retrograde moon around Neptune, say it was captured, okay, because that's how retrograde moons usually develop. They are captured. And you need three bodies to capture something. You need one, two, and then some third one to give it a kick to hold it once it's been captured. Because nothing will get captured with two bodies. You need three. So if you can capture a retrograde planet, maybe that's what did it. As I said, I didn't read the article, but planetary orbits are really interesting because they're not obvious. They don't have an obvious story to them. They need to be calculated by people who throw these things into computers and let them sit and chug along. And what they do is they change the initial conditions, and then they said, okay, go. And then they watch for a couple of billion years to see what happens. So that's probably what they did with Neptune. They probably let it chug for a couple of billion years. But so I haven't read the article.
Yeah, yeah, exactly that. I posted it in the chat, or at
Let's
least the
see.
paper,
Oh, I
but
see.
I think there's an article in space.com and etc. I think it's from October of last year, but yeah, something along those lines. That's pretty much exactly what they did.
Yeah.
But it has to do with with a resonance effect with an initially unstable, kind of wobbly axis.
Yeah, the word wobbly I'm looking up because I don't
Yeah.
understand wobbly. But I like the idea, even if this isn't the same thing, but whether or not it is a migration of an ancient satellite or whether it hit, So the difference is something hits Uranus. You think of it as being struck by a pool ball. This is something that is hitting Uranus slowly over time, taking its time to hit Uranus. Because in the end, the effect is the same. You have two bodies, and they have angular momentum, each of them with respect to the other, and and when you add the angular momentum of the two bodies together, you get, in fact, Uranus with its axis pointing, pretty much parallel to the plane of the solar system. Uh, but so that angular momentum is uh, conceptually understood as being a arrow pointing in the direction perpendicular to the rotation. So for our Earth, the angular momentum of our Earth is graphically displayed as an arrow pointing out of the North Pole whose length is determined by the amount of angular momentum. So if you imagine those two bodies, okay, uh, uh, they would have had each an angular momentum vector and independently, and then the two of them together would also add a third angular momentum, the angular momentum of one around the other, and that didn't change because there's a little law of physics called conservation of angular momentum. So although This paper purports to give a different story. The bottom line is that it still required the addition of the angular momentum of that moon in order to turn Uranus on its side. So it's, if you will, a second order effect, because it still required a moon to hit the planet, even if it took a long time to do it. So I'm not as
Get
impressed,
okay.
you know.
So since we evidently did get hit by another planet, which
Yeah,
then created our moon,
right.
would the effect of an impact, similar impact on Uranus, have created more larger moons potentially? Because, in this case, it would have splashed more, and it would have contributed more material to Uranus's immediate orbit.
Right.
And would
But
we be seeing more moons around that, or maybe not, because they could have not been, you know,
right.
stable
There could
and
have been a
reabsorbed?
splash. There could have been a splash, but Uranus is mostly gas and some rock. There's the gas giants and there's the ice giants, and Uranus and Neptune are ice giants, which means that uh, they have more rocky material per cubic centimeter than than Jupiter and Saturn. Jupiter and Saturn are mostly just gas bags, with a couple of planets worth of solid stuff in the bottom. Uranus and Neptune has more solid stuff, but if something hit, I would imagine that the splash would have been such that it would have thrown up the gases, and the gases would have, because they would have interacted with each other, the gas molecules, they very quickly would have fallen back in. You know, instead of, if you
Right.
throw up if you throw up two planets, they collide, then you get a lot of pieces, right? Those pieces don't touch each other, so they're each individually determined by the gravity of the planet, and maybe they do, coalesce, because they do, if you will, ultimately interact by colliding with each other, uh, and you get the Earth's moon. But if a gas giant got hit with a moon or a planet, you would expect it would just puff up for a while, and maybe we lose some of its gases, but then ultimately it wouldn't be like making a moon. You wouldn't expect it to make a moon. At least the little physics I've got in my head says that. I love the
Okay.
question. I love the question
Yeah.
because one of the uh, one of my heroes was one of my thesis advisors. Carl Sagan was my last, but my first one was a guy named Tommy Gold, and his specialty was keeping a universe in his head, and he didn't know how to do math. He was very bad at math, but he could imagine the universe, and so he could speculate on cause and effect for things. So he got real famous for getting a lot of things right by guessing. Got proved to be right by other people. So what I'm doing here is I have a little universe going on in my head, and I'm imagining a collision with Neptune with another moon, and I've just told you that what the effect would be, and I'm being a little Tommy Gold here, and it's quite fun. Anyway, Tommy Gold was one of the
How
people.
big would a moon have to be to impact Uranus to push it onto its side?
Well, pretty. It would be probably pretty extreme, probably, right? I mean, it's
Yeah.
let's do an imaginary case. If the Earth, if you were to take the Earth and turn it so that North Pole is pointing down, okay, then that's changing angular momentum from +1 to -1. And in order to do that, you have to have something that has an angular momentum of -2. Uh, to turn it on its side, you need only an angular momentum of just -1 to sort of cancel the angular momentum of uh, Neptune. So I would say, on the basis of what I just said, that something would have to be pretty big compared to Neptune to essentially destroy much of its angular momentum, at least the direction of it.
So in our case, with Thea hitting us and knocking the moon out, did that contribute significant? That might have contributed significantly to our axial tilt.
Yeah, it's possible. It's quite possible. It's the entire reason.
It's the entire reason why we have axial tilt. And so,
Yeah.
can we? Would would that impactor be basically approximately the actual size of the moon,
Well,
or larger,
when they talk about Thea, they talk about it as being Mars-sized,
Mars-sized? Okay.
right? But it's all guesswork. They they put together a set of initial conditions, uh, and then they let it fly and see what happens, and then they set another set of initial conditions, and there's so many ways to choose your initial conditions. You can choose size, you can choose speed, you can choose uh, the direction of the impact. So, uh, so you can muck with at least those three parameters, and so there's no way in the end for you to pin down all three because there's too many degrees of freedom. So it's like having, two equations and two unknowns as one solution. But how about 10 equations? How about two equations and 10 unknowns, right? Well, there's lots of solutions to that, and you can muck with 10 of those, 8 of those variables to your heart's content and still fix it with the other two. So there's no way of really knowing what those answers are. You just try to pick things that you can justify, you know.
So that's the long form answer to Jack's question about why is it warmer in the summer.
Uh, no, I think that in this
Funny.
case it is pretty much what I
Yeah,
said.
yeah, yeah.
Not in other words, I don't think what I said is debatable.
Right.
It could be wrong, of course, but
It could be wrong, just understandable.
just not debatable, right? Right. I mean, because
Cool.
I'm holding myself out here as some sort of authority, but in fact, all I am is some guy who's been interested in this stuff my whole life, and I have a better take than most people.
I think
So,
that's the definition of authority.
right.
I have some news.
Yes.
Paul Davison, the co-founder of ClubHouse, just gave
Oh.
an update about 4 hours ago on his personal
Oh.
account.
Uh-huh.
Um, Laird, are you aware of what he said?
No, not at all. Please tell us all.
He unveiled some new product updates that are going to be unveiled at the later part of this week. And my best guess is that this is good news for this room. One of the big updates they're going to unveil is that they're going to return the hallways back to the app,
Oh. Oh,
so
good.
that people who aren't necessarily following you can actually find this room,
Yeah.
especially when it's live.
Right.
And they're going to make a bigger push to make the live rooms more of a deal. And this could be a really good thing, or this could also mean that their plan to reinvent Clubhouse failed.
I think their plan to
Yeah, I'm
reinvent
going with the
failed.
latter.
Right.
I will
They.
say that what really concerned me about his announcement, and again, this is the co founder of Clubhouse, is that only 300 people were listening to it.
Yeah. Yeah. Yeah.
Wow.
Yeah. Right. I
It's
have
to get
my
1,400.
I have my list of objections. One of my new objections to Clubhouse is, if I look at my the houses that I am a member of, they go on forever. There used to be like 12, and now there's 1,200, something like that. I'm exaggerating, of course, but it's now an activity for me to leave houses and to reject invitations. I am constantly doing that now. It's annoying. So hopefully they'll do something to make it less annoying.
They did announce a bunch of bug fixes that are supposed to happen in the next couple of days. That also include adding rooms like this to your calendar so that when you actually do want to be here for it, your phone will actually ring and tell you, which, for instance, your daughter still can't figure out how to make that work on her phone.
Yeah, I don't know how to make it work at all. I abandoned all hope when I entered Clubhouse. I just do my little room, and then I disappear gently into the night, and don't pretend to know how to get in and out of anything but my own room. It's it's and and in fact I don't in fact I don't understand. You can all tell me, what's the purpose of Clubhouse as far as you're concerned. As far as I'm concerned, your purpose of Clubhouse, as far as you're concerned, is that you come to hear me, go on every week. But why do you come into Clubhouse besides listening to me? What is the purpose of Clubhouse from the point of view of everybody else who's in the room? Why are you spending your precious time listening to these people go on sometimes without any rhyme or reason? Why are you people here? I don't know.
Well, in,
They're all
in my case,
bots.
in my
Yeah,
case
they're
in
all bots.
point, I'm going to satisfy your ego because it started off during the pandemic, and it was just, you know, a way to talk to people. But now my entire reason for Clubhouse is this here right now. Uh, this is the only thing I participate in. So
Thank you.
the reason for Clubhouse for me is basically you and your room. That's it.
Oh, well, so Jean-Frederic, Jack is going to Florida in a few days. Okay, they're going to Naples, Florida, I believe.
Oh, okay.
Are you anywhere
You
near
know, an
Naples,
hour and
Florida?
change. I'm in
North.
Sarasota. I'm,
So
an
Jack, if
hour
you
and
want to
change
visit
north.
Jean-Frederic, he's right there. So Jack, if you want to visit
When are you coming
Jean-Frederic,
down?
he's right there. The 24th they're coming down.
When are you coming down?
The 24th
Unfortunately,
they're coming down.
I'm in. I'm
You're in
leaving
Switzerland?
tomorrow. Unfortunately,
For
I'm
Switzerland?
in.
Yeah.
I'm
Oh,
leaving
Switzerland.
tomorrow.
That's too For bad. Switzerland.
Yeah, I'm heading over to
Oh,
see the
Your
folks.
that's too
daughter right
bad.
now is
Yeah,
shaking her
I'm
head,
heading over to see
wondering
the
why your
folks.
daughter right now is shaking her head, wondering why you've just given our itinerary out to a bunch of strangers.
Yeah, yeah.
Well, uh, I didn't say the flight. And and why would some? Okay, so you're thinking that somebody in the audience is evil and planning a coup of some sort? Well, yeah. In that case, there's probably enough. You're right, Jack. There's probably enough information that I revealed to, in fact, uh, you know, uh, and we have a picture of Orion here, right? And he's the only one. So you recognize him. So I suggest,
Actually,
Well,
I changed the picture.
okay.
fair enough. It is Florida.
Yeah, if we wanted to be safe, we wouldn't be going in the first place.
We
So.
wouldn't be going in the first place.
Right,
So,
the day before Christmas. What are you thinking?
yeah. Well, it's a good place to be in for Christmas. I mean, it's not, you know, Santa doesn't exactly wear shorts right now, but it's not bad.
How big of a mistake are we making by going to Naples, Florida? Well, that just
I
said
mean,
enough.
what are you going? What are you going there? Who's in Naples?
My uncle, the one with all
Oh, okay.
the AR-15s. He's
Yes, that's the reason why you'd be going to Naples. Yes.
Harisa's laughing, but that's not a joke.
No,
No, if he's
no,
in
it's not
Naples,
a
I
joke.
believe it. But my
Yeah.
mother lives in Sarasota. I'm familiar with
Could we get an
Okay. Hey,
address or like a zip code or something?
that.
Well,
In
let's not
case I
do
need
that.
backup, sure, why not?
a pin on Google Earth. Yeah. No, it's. I mean, no, it's nice. It's it's Florida, and a bajillion people who have been moving to Naples recently can't all be wrong. Maybe they are. But Sarasota, if ever you want to come up
Lovely
this
area, love
way.
Sarasota. Shout out
Yep.
Sarasota.
Well, I understand it's nice in the winter, but why would you go there? Why would you live there during the summer?
Uh, well, because I'm busy screwing up the place. I'm an architect.
Oh,
What do you
so
want? I mean, this is my bread and butter. It doesn't stop.
right. Do you build individual houses or do you build commercial?
Oh, everything. I'm working simultaneously right now on a obscene single-family residence and a stadium.
And a stadium. Wow.
So, yeah, we do it all. I mean, I've worked on pretty much every typology there is, short of an observatory. Although I did put in a proposal for a science museum. So, I mean,
And
yeah, we do it
when
all.
you do
Stadium in Sarasota or somewhere else?
Tampa Bay. The
Oh,
USF Bulls Stadium.
oh,
when
okay.
when you do
Yeah,
your
University of South Florida, Tampa is doing a stadium
when
now.
you do your work, is it you Superman against the hordes, or are you a team of one of 100? I mean, what size is your? I I mean, what piece of
Well,
the thing do you do? The whole, the small? What do you do? The bathrooms?
it depends on the yeah no, it depends on the scale. Well, right now I'm doing the bathrooms in a stadium, among other things. But yeah, so if you're talking about the stadium, the team is probably north of 100 people.
Okay.
But my other projects, I have been a solo actor, or in any case, we generally have consulting engineers. So probably never less than 6 or 7, and north of that.
Wow. Okay. Yeah.
So, so if I'm working on a $60 million hotel, we're probably going to have like 20 people all told.
Okay, so if you're working on a hotel, I have a complaint. Okay, I want to
Yep,
I want
yep.
to know why I've never been in a hotel that has a nightlight in the bathroom. So for when I would go in the middle of the night, I don't have to leave the light blazing. Why is there no nightlights in any hotel I've ever been in?
Oh boy. Yeah, yeah, that is a good one, and that's because I'm going to give you a bad answer. It depends on which flag the hotel is flying, because, for example, Hilton has extremely nitty-gritty specifics on the photometrics of its rooms, and they dial in the lights to the nth degree, except they don't spend the money to actually, put in a nightlight feature into their fixtures.
Right. Okay.
So there's
There's
that.
that. Uh,
There's that. It's it's a cost that's spread over multiple hundreds of rooms, and it's just one of those things that is VE value engineered out.
right. And now,
Yep.
uh,
Value engineered out.
another question.
Yep.
We were the victims of a fire drill. Okay. When we were at a Hilton hotel, I believe, uh, and it turned out to be some sort of false alarm. Uh, why did the entire hotel have to leave the building?
Because smoke goes up,
Uh-huh.
and it depends. I mean, was it a high rise or was it a low rise?
Jack, um,
How tall
I
is this
wasn't
building?
there.
oh, no, I guess you weren't. I'm trying to remember.
It,
I'm just, oh,
Tara says it was
But
a high rise.
okay.
in general, when there's a fire alarm, they evacuate the building. Period. They're not going to split hairs.
Uh-huh.
There's a whole crap ton of stuff that happens when the fire alarm goes off. If you're in a high rise in particular, for example, what happens is the AC system reverses and they pressurize the floors above and below the fire, and they depressurize the floor where the fire is, and there's a smoke evac system, and there's all this stuff that goes
Really?
on.
Wow.
But oh yeah. It's quite a production. But in the end, liability wise, they just evacuate the whole freaking building.
That's interesting. Wow. Okay.
Yeah, that's pretty much my entire job.
Which is what?
It's well, architects. Our primary purpose is life safety.
Really?
So my whole job is, I mean, design is 5% of the job. Most of it is, if it catches fire, you got to get out.
So now you're telling me that much of the design is designed around safety rather than, you know, uh, the nitty gritty, the piggly wiggly little details. It's how to get out.
Aesthetics.
Yes, yes. My primary purpose is the life safety plan, and that's item number one. So if you can't get it, and that's what the whole code, building code, and everything is all around. So whenever you see, well, you rarely see it anymore. People don't die in structure fires all that much anymore compared to historically,
Right.
which is a sign that we're all doing our jobs. But yeah, if you see an article where there were 20 people piled up, asphyxiated at the end of a dead end
Right.
corridor, that's the architect's fault.
What happens if the person who owns the building decided not to let in riffraff, so they locked the door?
Yeah, that's his fault.
Yeah,
Yeah, that's the mitigating factor right there. So if there was a padlock on the door, it's not me.
But you should make it so that they can't put one on the door.
Well, that's why you don't see double doors with two handles on them anymore.
Oh,
Because there was a stand-up
Oh,
comedian, I can't remember what his name was, who had a whole shtick about, I don't understand why bike locks are something that you can just buy on the street, because I can just buy a bike lock and then go to any Starbucks and say, you're closed, click.
right.
Yeah, that's why schools and so on do not have two handles on the exterior doors
Wow.
on a double
So
door.
Kellen Erskine.
that is fascinating. Wow, I never thought about that.
Yeah.
The comedian's Kellen Erskine.
Oh, okay.
I saw that bit.
Yeah.
Right.
Yeah.
Yeah. Design is interesting. What do you think of the? Let's talk about spaceships for a little bit. What do you think about the design that Elon Musk has created, in which the upper stage of his SpaceX Starship thingy doesn't have a way of people escaping in the eventuality of an aborted launch?
As in there's I'm not quite familiar with it. I know that there isn't that little rocket at the top that pulls the top
Right.
off
That's right.
anymore. But I imagine they can just jettison the crew capsule by itself without the escape rocket. I
Yeah. So that's
did they bury that feature in the bottom rather than in the top?
It's an interesting thing. It's a discussion that I've seen on YouTube, which I haven't seen recently, but it strikes me as being a problem. I mean, for instance, if you get into an airplane, uh, there's no uh, there's no button you can press. There's no ejection seat, you know, in an airplane, right? The best has got exit doors, uh, but in a starship, uh, that thing is going to blow up pretty quickly, and I don't know how they plan to deal with that. You know, uh,
Well, I think they abandoned that approach with the space shuttle because there wasn't a very good way of getting out of the space shuttle when if ever it started burning up on the launch pad.
that's true. That's true.
They had to unbuckle, get themselves out, go to this thing, get on the rope, hook up to this rope and basically slide down.
Right. They did have
I
something.
mean,
They did have something at the launch pad
those,
that
yeah,
was like
the
that.
seconds. the seconds tick pretty slowly, I think, when you're trying to get out of a burning spaceship
I
Right.
bet.
Right.
on time compression right there.
Right. Hold on a second. Just talk among
But
yourselves.
yeah, but egressing out of a spaceship is not my forte. But yeah,
But design is interesting because you spend your day all day in the question of design. How much does politics get involved in your designs? In other words, are you ever told to do something that you think is wrong, but your boss tells you to do it anyway?
my boss being the client in this case, and well, money talks, but there are many varying degrees of wrong. So wrong in design is one thing, but when it comes to a point where life safety is impacted, then that's where I get to draw the line.
You actually have authority to draw the line when you say it's not safe. Stop that.
Yeah, that's the only reason why I have a state license.
Aha. So,
That's why I have to be licensed by the state of Florida in this case.
Because then you have liability, right?
Oh, all kinds.
oh,
Nothing
I
but.
know, I know the question I wanted to ask. Are you ever, when you design a building, you design it against a hurricane? Do you
Yeah.
ever design it against earthquake?
Nope. Not in Florida.
Right.
I still have to take some seismic, structural component to my exams, even over here in Florida, because it's a national test. So California wags that. So I still have to learn, seismic stuff. But Florida has absolutely no seismic activity whatsoever. It's the only state, actually, I think, that doesn't.
Would you be able to say anything about whether or not buildings in Manhattan are designed in any way for earthquakes?
Yes, but to a much lesser degree. It's a question of incidence. So it's a question of what kind of systems do you put in place. Basically, they're designed for stiffness rather than bending.
Right. So if I took my 100-year-old building and shook it from the bottom, and it's got a brick facade, and it's concrete. I don't think it's steel, but I think it's concrete. What would happen?
Oh boy. You'd probably shed a lot of bricks. You would don't stand anywhere around that building. It might be for New York, for a New York earthquake, it might be stiff enough. The biggest problem that you have is with a soft ground floor. So typically, since the ground floor is commercial in a lot of buildings, they have a tendency to be wider. So buildings that have a soft first floor have a tendency to just imagine it just sitting down,
Really?
right? It slides over sideways and it collapses by its knees buckling. And just imagine a whole building sitting down. So during the Christchurch earthquake in New Zealand in
Yeah.
2006,
Yeah.
I think there were about 150 people killed, and half of them were in a single building that had a soft ground floor. And the whole thing just basically buckled at the bottom and then pancaked straight down.
Wow.
Yeah.
Oh, wow.
You know, New York City has the same frequency of the same graph of the frequency of earthquakes as does San Francisco. If you, but the,
Does it
it
really?
does, but you have to shift this graph over about 3 orders of magnitude. In other words,
Right.
the frequency of the large ones is 10 times less than the frequency of the small ones. in San Francisco as well as in New York. But the chances of a large one in New York is like 100 times less. I'm making those numbers up. Uh, but the graph of the frequency versus uh, 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 size is in fact the same.
Well, and New York is on granite, so all of your structures are built on granite. And what I really love about the concrete that you guys use over there is that granite is your aggregate. So you can have what we, 10,000 pound concrete, 15,000 pound concrete. That's PSI, compressible
Mm.
strength. Florida has 3,000, 6,000 pound concrete because we're using crap.
Oh,
We're using, we've basically got limestone aggregate. And so my shear wall that I have to design 2 feet thick, New York can get away with half of that.
wow.
And so by the sheer materials that you use, you can design much more stiffness into your buildings. And for your teeny tiny earthquake that might, have a smaller amplitude, and it's just going to, judder with a very short frequency, it's not going to sway your building that much.
That's interesting. There's a my neighborhood has the number one train, and two and three for that matter, and it goes north. And by the time it reaches around 125th Street, the subway comes out of the ground, and it's
Right?
about 30 feet into the air, and then a few 100 meters further on, it goes back into the ground. And the area that it comes out of the ground is a fault line right
Right.
through Manhattan. And
Oh,
and there
wow.
are other fault lines that they have discovered that go through Manhattan. So although it's infrequent, it doesn't mean it doesn't happen. So we are safe from earthquakes, more or less.
Well, I seem to recall once upon a time, and this might have been in the early 2000s, there was a building in Harlem which just basically, because of a water main break that undermined a gas line, it, 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 it did something, and this whole building disappeared into the ground, and a 7-story building
Oh,
became
I
a
remember that.
one-story building. It just collapsed straight down
Wow. Yes.
into the ground, just like that, just phew.
Hmm.
And and so considering the Swiss cheese that is the substrate in New York at this point, I don't honestly know what would happen
Yeah.
if an earthquake hit
I,
New
I,
York, and I don't think anybody
I
does.
do like the land on which I sit because uh, there are brownstones on my block, and sometimes the very rich and wealthy buy one of these brownstones and renovate it top to bottom, and they put in the basement. And in order to put in a basement, they have to dig it out, but it's not sand; it's bedrock.
Right.
And so you see these dumpsters on the street with bedrock, Manhattan bedrock, and I have gone by and picked up some bedrock. It's up here in the country where I'm right now, Manhattan schist. It,
Dad,
yes.
I'm going to bed.
Okay.
See you
Uh huh. We'll
tomorrow.
see you tomorrow.
Good
Hey,
night.
good
Night.
night.
Right.
Go to bed, Grandpa.
Actually, that's a good idea. I mean, I really am sick. Uh, I've checked myself for COVID, Tara. I don't have it.
Yeah, you sound like you have a cold. Like,
Yeah,
are you
but
feeling all right?
yeah,
Oh,
I feel terrible, but I can do this and feel terrible, and that's interesting.
it's a flu. It's a flu. Everybody I know has had it, and I'm just coming out of it as of
I
yesterday.
have no temperature though. I
Yep.
don't have temperature. Uh, it's just a terrible feeling of a body ache. But
Yep.
yeah,
Yep.
oh
Yep, I had a brief temperature, but no, body aches and chills and
yeah,
just and if your head is completely stuffed, then yep, that's
oh,
it.
nice to know.
Well, Laird, you have a banana bread waiting for you.
Ah, is it? Does
That's
it have poppy seeds on it by any chance?
that's not
What
banana bread.
does?
That's a lemon
Oh,
cake.
okay. Yes, that sounds very interesting.
Can you make it with poppies?
No, I just thought that's my memory of what it looks like. Uh, Entenmann's banana bread, banana cake, something like that. Yeah, but anyway, thank you. I'm looking forward.
There is no other food in the house, by the way. So
Well, that's because you ate it.
there's that.
That's because you ate it. I like to diminish the stores. There's supermarkets right down the block, and you're going to go shopping tomorrow, probably, right?
For those who don't understand, Laird has a nuclear bunker in his Manhattan apartment filled with canned goods from the 1980s,
Yeah,
and for the past couple of weeks, he's been hiding out in his place near the Berkshires,
right.
and has left us to run amok through his cabinets. So
Oh, so you've eaten?
we've eaten him out of house, home, and Hellman's Light
Yeah,
mayonnaise.
Well, I hope that bread's not from the
no,
80s.
no, no. Jack,
No, I just made that.
Jack is Jack is Jack. The way that I am forced to talk about astronomy because it's what I live on. Jack is forced to make dishes, and he can't stop himself. It's just
Well, your daughter's the one that makes the dishes. I just make the food
okay, right? No, no, really, it's interesting because we all
That's
have our
because she's a
things.
ceramicist.
Oh, oh, right. That's it. That is true. That is true. By the way, some great dishes that she's made. Uh, I can't believe that the people in the audience are still hanging around listening to this conversation.
Who are
Uh,
these people that would listen to this kind of
I know. I want to know.
pablum, if anything?
I mean, really, seriously, this conversation is degenerated into pure pablum. Is the right word? Yes.
I would love to know what
that's
Janice, Richard, Nate, Mark, or Dash Bradford get out of this.
Well,
But
Dash
so I'm
comes frequently, and there are and Richard comes frequently, and Mark has just invited him, asked to be a speaker, so he can comment on this
so
stuff. Uh,
I'm going to retire now, but I just wanted to say that we have added one inkling to the astronomy question, which is how astronomers feed themselves, and this is insightful.
yes,
1980s canned
They
food.
19.
or they surround themselves with people who will press food upon them as they peer into the mysteries of the universe.
Right.
Keeps them grounded, right?
Yes, so that is great.
I was nerding out on the seismicity discussion and the difference between New York and California. I'm a dam engineer,
Oh,
so
you're a damn it.
I'm kind
Is that you, Mark?
yeah. I work with
Uh,
dams. I'm basically the chief engineer for Virginia for the
oh, so
dams, the 25.
so you're like an expert on what earthquakes are your meat and potatoes, right?
Well, if I was in Washington State, they would be, and actually that's probably why I never became a dam safety engineer in Washington. But in Virginia, it's all about hurricanes and water, and those are the loading conditions that we're most concerned with. So and that was actually my specialty was my master's in civil engineering specializing in the environment and water resources.
Right. I have a damn question. It's not a damn question, but the other day I was thinking, why don't we build a pipeline to pipe water from where there is water to where there isn't water? Why don't we do that?
And that's already being done in California on a massive scale. They're taking Northern California water and sending it over the Tehachapi Mountains and
Right, but
getting
why
it
don't we
down there.
send it from the East Coast where we have too much of it to the West Coast where they don't have enough? No, no,
It's a
The,
damn good
yeah,
question.
the Rocky Mountains might be part of it, either very expensive tunneling or a lot of pumping costs. But
right, but
and also it's yeah these massive. I think there was once even an interbasin transfer that was being proposed from Canada down to Los Angeles. It was, kind of out there, but still feasible, but maybe not economically feasible proposal. But it was actually getting a lot of active discussion, I think, in the 70s.
no, like for instance, let's say that you build a water tower that's 1,000 feet high, okay? uh, enough to basically clear the Rocky Mountains at its lowest point. And you station it somewhere in New Jersey because New Jersey doesn't really care about its environment, uh, and and then you pump the water up to the water tower, and then it makes its way across the entire continent, and it solves the water problem that the the West Coast is having. Why don't they do that? I'm sure the answer is money, but is there any other reason? Is it like a factors of 1,000 wrong, or is it just a factor of two wrong?
The environmental NEPA documents alone would be um,
Yeah.
huge for a project like that, because anytime you're mixing interbasin water transfers, people really get excited about that, even especially in the West, but potentially in the East as well. That's
What's
why
an interbasin transfer?
California is actually building projects again. They've woken up to climate change, and they are actively considering how they're going to deal with a rapidly changing snowpack melt
Right.
pattern result of warmer temperatures. So they're one of the solutions that they're looking at is to increase storage. And they also have to do thermal releases in California, so
What's that?
they can release.
What's that?
They release very cold water from the deepest levels of the lake during the peak summer heat season, or because otherwise the fish would die.
Uh,
So they have these multi intake structures that allow you to like open and close shutters at different elevations to get water at different temperatures into the river for diversion.
the Lake Mead, which is what fuels Las Vegas, right? Uh, uh,
Hmm.
it strikes me as a person who knows nothing about this that that's a disaster waiting to happen. What do you think?
Well, it's already a power crisis situation because the hydroelectric power is totally
Mhm.
on having a full reservoir or as full as you can operate it without spilling too much. And they're down at the historic lows at both Mead and
Powell.
Powell upstream of it, Mead. So yeah, and there was such a shortage of water prior to the arrival of numerous atmospheric rivers that the seven Colorado Basin states were forced basically to enter into an agreement with each other on how the shortage would be shared.
Uh-huh.
And that was a huge undertaking to get California on board with the other six.
So is it possible that Las Vegas might quietly disappear into the night?
It might become like more of an exclusive place, I guess, because the water bills would be out of sight, I guess, at some point.
Right.
But
Yeah.
the only
Is
people
it too?
who
Is
want to
it too?
play, and it's gotten a lot more expensive than when I worked there. I worked there in the when was that, in the '98 time frame. I spent a fall working on projects down there, and it was very cheap. I mean, I would sign up for all the promotions, and people would send me a Caesar's Palace suite with my own living room with a big hot tub in it,
Yeah.
and it was like $50 a night because they were trying to get people to come in and gamble. And of course, I was coming in and going to work, and I made a point of going out at weekends so I didn't gamble my $35 a day food per diem away or something.
Right.
And to what you were just saying, Laird, like Lake Mead, even with all the atmospheric rivers over the summertime, Lake Mead is right now only at 38%
Really?
capacity.
And I think it goes down as low as close to 19, but I'd have to go
Yeah.
Wow.
check.
Wow.
So it's
Is it?
double.
I live in Denver, so like water's like always on the news here.
I have a question, Mark. Is it too? Is it oversimplified to say like Walmart shouldn't exist in the desert type of thing, and that's why this we shouldn't have Las Vegas, we shouldn't have Dubai.
Well, Dubai is a
Yeah.
separate issue, right? Because it's funded by oil money, right?
Yeah, but there's only so much water, and when you look at desalinization of water and that type of thing, when you look at the issues that Las Vegas has with with water issues.
Part of it is a lot. There's a lot of what you're seeing there is recycled, but as you might imagine, the evaporation losses in the Los Angeles climate are pretty
What do
extreme.
you mean recycled?
So they use the same water over and over again. They have what they call gray
Yeah,
water systems that are not potable
right.
water, but you can use for like irrigating golf courses and median strips and things. It really, yeah, you're right. It really shouldn't exist. And most people have had to go to native um, plants and cacti and things like that, and more of a gravel garden rather than a lawn garden.
Right.
It's just prohibitively expensive to
Is it possible?
have
Is
a.
it possible? So you know about also you know about recycling water, right? You know that, right?
Yeah, I've dealt with it probably more theoretically than practical. Most of my practical experience has been in hydropower and
Okay.
dams, but
Because I am always interested in how they clean the water that they dump into the Hudson River where I am. And if I'm pouring paint down my toilet, which I am completely capable of doing because, what do I care? I'm just a New Yorker.
Mhm.
It's they have to work. Of course, I've never done that. You understand, but and
paint thinner might be worse or
but
acetone, but
but you
yeah,
don't
yeah.
know what people pour down their toilets. I mean, you really don't know what to do. And how do these water recycling plants? How do they deal with it? All the chemicals that people put into the water, do they take it out? How do they even begin to take out all the harmful chemicals that New Yorkers put into their
So here's a
water?
really good example of the trail of danger that quote horrible chemicals can cause. And in this case, it's the estrogen and birth control pills that
Really? Yeah.
come out in the urine, that go into the sewer system, that go into the water,
Right.
and that water goes into the Columbia River. And now you have weird salmon deformations, like asexual fish or fish that are like uh, both sexes, and you. So it doesn't necessarily take out, unless it's specifically designed for that. There's a whole field of industrial wastewater treatment that is geared towards, and it uses chemistry as part of the treatment process to break down, certain materials. But most municipal sewage is geared towards crap and toilet paper
Yeah. Right.
and
Exactly.
garbage disposals. That was a big wild card when it came out early in my career, the garbage disposal. And a lot of the wastewater treatment plant designers had to kind of rethink how they were going to deal with not only waste, but organic food products that had just, gone down the garbage
Right.
disposal, which, of course, a lot of.
In California, they're because of so much water is lost to the oceans. With the way their drainage is set up, their voters, I believe, are going to start voting next year on what they're dubbing toilet to tap programs, where they're going to hook up massive reverse osmosis systems to the sewage system, so that by like the wastewater that would come out that um, is largely okay would actually that would get recycled into drinking water
Yeah.
through reverse
I,
osmosis, but they're mad expensive.
I just find that I don't know the chemistry, but it strikes me as being uh, impossible. You know, basically because I
Well, reverse osmosis can filter out water down to the molecule. The filters are that good; they're just mad expensive. That's why they're not all over the place.
uh,
They're incredibly expensive filters, incredibly expensive electricity wise. Um, so that's why it's most systems just treat the water, then they let into rivers or streams. But reverse osmosis can get down to individual molecules of water.
really,
Isn't that how the astronauts had their water supply? Because they would recycle their urine and
yeah,
Pretty
but
much,
but
yeah.
in the astronauts at least know what this stuff is they have to recycle. No, really. I mean, I'm just
They have taste as well. They're not, going to drink anything that comes out of the tap, so to speak. They're going to want a certain level of odor and color and taste control on their reprocessed water.
right. I have lots of chemicals I do dump into my toilet, but they're usually in the realm of medicines I take. Uh, you know, and but nevertheless, there's medicines that just go into the toilet, and and you're saying those can be excluded.
Those persist. Yeah, those can persist.
They can persist. That's what I think. Yeah.
Yep. And there's three different levels of sewage treatment that are talked about typically. The primary, which, believe it or not, I don't know if it's changed recently, but Victoria, Canada was still using primary sewage treatment plant, kind of like early 1900s style stuff. And then
Oh,
secondary does a more thorough job, and there's settling basins and clarifiers and other things, and you get a pretty good product. And then tertiary, basically produces water like comparable to like a river. So it's quite clean. And like if you're like discharging water into Lake Tahoe, you're probably going to be discharging tertiary water, not primary or secondary treated water.
Well, uh, I'm feeling increasingly ill right now, so I'm feeling like I'm going to want to terminate this. Uh, but
If you think you feel bad now, I just used up your last bottle of Rouse tomato
oh,
sauce.
really?
oh, that's such good
Oh,
stuff.
wow, that's terrible. No, really, that's no, really, that's the answer. That is the answer to many questions. Uh,
It is the
Rouse tomato
42 of
sauce.
Laird's Kitchen.
right. No, really, it has. Uh, I'm very thankful that it's made its way around my area that I live in. It's in all the supermarkets in the Northeast that I've been in, and I like particularly the giant economy size, the 32 ounce, because I like to smother my stuff in sauce, and it is the best.
It really
Yeah,
is.
right.
What's the brand?
Rouse, Raos. There, my Tara, who was featured in the picture
Really
of Jack,
good.
so that's my daughter Tara. She went to a school on the Upper East Side, all the way near the river, in Harlem, and uh, nothing there really survives very well except an ancient, I don't know how old that is, uh, uh, Italian restaurant that you cannot eat in because only the rich and famous can get a reservation, and that restaurant is called Rouse. Uh,
Oh, okay.
and the
I don't know.
picture on the label shows the front door of Rouse. So it is exclusive to begin with. Never, in all the years that Tara went there, we were never able to get a reservation, and we went there every day. So they only open the book twice a year. So it's a very good to spaghetti sauce. I recommend the arrabetta. How do you say it? Arrabetta, arrabetta,
Arrabbiata.
arrabbiata. Yeah, that's really good. Uh,
It's a
yeah,
119-year-old restaurant,
really.
and now they
Oh,
only
wow.
open the books once a year in November.
It's like 24 tables or something like that. Right. Yeah. So now we're up to spaghetti. Uh, uh,
Yeah, man, I'm getting hungry now. Hey, but Dr.
yeah.
Laird,
Oh, hi,
not to
Dash.
sound corny or cheesy.
Hi,
Hey,
Dash.
man. Good evening, everybody. Well, good morning.
Yeah.
I just been listening to you guys. Not to sound cheesy, but water too, man. Like if you feeling ill, a lot of water.
Yeah, that's what I'm
That
trying to
always
drink it.
helps
Thank
me.
you. But as I started this conversation very early on with Alan, the first thing he said water, and then the next thing that I said was I'm going to write a book called The Joys of Peeing, because because it turns out that at my age it's actually a joy when you can get a good full flow, and I can't do it with this disease that I've got. sorry about that.
It's all good, man.
Anyway, go ahead, Tosh. Sorry about that, boys and girls. I have a very low barrier to keeping my mouth shut. So anyway, go ahead.
Well, now we're back to prostates. Okay.
Right. We,
That's
You
the,
just
the,
you just say you have a very tight ureter.
right,
fine.
right. Uh, no, really. So I should end this. It's late. Close to my time. The topics have degenerated to what I started with, which is my prostate, and so there's no point in continuing. And so I will be hopefully better next week. I'll be here Tuesdays, and maybe Clubhouse will fix itself so I can do this. I really am interested in trying to talk about astronomy. Believe me, uh, and so we will try to resume our classes next week. Same bat time, same bat channel. If anybody's old enough to know that phrase, uh,
Yeah.
it comes